So let's discuss a problem from GATE 2021 Physics. This is from quantum mechanics, a problem from quantum mechanics, and it is related to the harmonic oscillator energies and wave function would be given, and we need at a certain time, and we need to find out at what time it is orthogonal. So let's look at the problem. So this is the problem. So consider a state described by xi of x comma t is equals to xi2 of x comma t plus xi4 of x comma t. So this is the required state xi of x comma t, where xi2 of x comma t and xi4 of x comma t are respectively the second and fourth normalized harmonic oscillator wave functions. They are the harmonic oscillator wave functions given second and fourth, they are, it is said that they are normalized. That means xi2 star into xi2 and xi4 star into xi4 is nothing but equal to 1. Normalized wave function, this is the condition, it must be equal to 1. And omega is the angular frequency of the harmonic oscillator. So they have given the frequency of the harmonic oscillator. The wave function xi of x comma t equals to 0 will be orthogonal to xi of x comma t at time t equal to. So finally what we need to find out is this is the wave function at time t equals to 0, and this is the wave function at certain time t. So we need to find when this wave function is orthogonal to this wave function. So for that, so here what they have given in the question, this was given xi of x comma t is equals to, so the same thing, xi2 plus xi4, so this was given. So at certain time t, time dependent wave function is given as at the position x at time t, it is nothing but xi n of x into e power minus I e and t by h cut. That means energy of that particular nth state, nth level. So this is the form we need to remember. This is the standard form of the wave function which is depending on time. So here what they have given to us is xi2 of x comma t. xi2 of x comma t would be written as xi2 of x into e power minus I e to t by h cut based on this formula. In a similar fashion, xi4 of x comma t could be written as this, xi4 of x into e power minus ie4t by h cut. So this could be written in this form. So now what they have asked in the question is xi of x comma t equals to 0. That means xi of x comma 0 must be orthogonal to xi of x comma t. So we need to make at time t equals to 0, we need to find out. So when time t equals to 0, what we would get is xi2 of x as usual. So here xi2 of x is as usual, and e power minus I e to t by h cut in the place of t0. That means e power 0. Anything power 0 is 1. So only xi2 would remain here. Here also xi4 would remain, and e power 0 we would get because time is 0. So e power 0 is nothing but 1. So xi2 plus xi4. So finally we would get this. So xi of x comma 0 is also xi2 plus xi4. So this is the final thing we are getting. Next, xi of x comma 0 will be orthogonal to xi of x comma t. So this was the thing we needed to find out at what time this would be orthogonal to this wave function. Xi of x comma 0, that is wave function at time t equals 0 must be orthogonal to this wave function at some particular time. So that time we need to find out. So orthogonality condition is this, xi star of x comma t into xi of x comma 0 is equals to 0, because this has to be orthogonal. This both wave functions have to be orthogonal. So only possible way is, this is the condition, xi star into xi is equals to 0. So now we need to simplify this. So xi star of x comma t, so actually this is This is xi of x comma t. Xi star of x comma t is nothing but in the place of I we need to replace it with minus I. That means here in the place of I we need to place minus I. So if we place minus into minus plus e power e to t by h cut we will get. Here also in the same manner in the place of I we need to place minus I. So plus we would get in the powers we would get plus. So here you can see it. So xi to e power I e to t by h cut, e power plus I to e to t by e for t by h cut. And next we are taking xi star of x comma t. So we after while taking xi stars onto the both sides, what we would get, this also would get converted into xi2 star. Xi4 would get converted to xi4 star, as this plus I has been converted to minus I. So in the similar manner, xi2 to xi2 star, xi4 to xi4 star. So this is the thing we are getting in the place of xi star of x comma t. And xi of x comma 0 is as usual. So xi of x comma 0, xi2 plus xi4, same. So next is, now we need to simplify this. So here, so it is of the form a plus b into c plus d. So in this process we would get four terms: ac plus ad, bc plus bd, like that, total four terms. But it would be reduced to two terms only based on this condition: xi I star into xi j. So this would be equal to 1 only when I is equals to 1. I is equals to j. That is xi1 star xi2 star xi2, xi3 star xi3, xi4 star xi4. All of them would be equal to 1. Not only if we consider xi1 star xi2, xi2 star xi3, xi3 star xi4, so that would be 0. So that is the case when I is not equals to j. So that one we need to see here. So here, so this xi2 star e power I e to t by h cut and this, they both multiplied together, what we will get, xi2 star into xi2 e power I e to t by h cut. So that is one of the thing. And this, and next is this xi4 star into this xi4. So xi4 star into xi4 e power I e for t by h cut. So here based on this condition, xi2 star into xi2 1, xi4 star into xi4 1. That only if we would get another terms also, xi2 star into xi4, which would be equal to 0 because I is not equal to j. In the similar manner, xi4 star into xi2, that also would be equal to 0 because I is not equal to j. So finally we would end up with these two terms. And now, so this is equal to 1, this is also equals to 1, because in the question it has been clearly mentioned they are ortho normalized harmonic oscillator wave functions psi2 and psi4. So it was given clearly in the question. So this one would be equal to 1. So what would remain is this one from here, and in this term this one would remain. So next, so now we need to send this one of this term to that side. So it would become it is plus here, so on going to that side it would become minus. And now what we need to do is taking e power, we need to send this to that side. So it is just like a into b. So now it is just like a minus b. So if we divide it with b on both sides, what would happen? A by b is equals to minus 1. So like that. So simply that is the thing. So if we send this to that side, what would happen? So here it is multiplying, there it would divide. So we would get minus e power minus I e for t by h cut, and this is e2 as usual, and here minus 1 would be remaining. And from this, if we, this is of the form a power m into a power n, a power m plus n. So e power minus I e4 plus e2 t by h cut. So if we take minus I common, so from here if we take minus I common, e4 would be remaining, and from here minus I if we take common, minus into minus plus. So minus into minus plus, that e2 e4 minus e2 t by h cut. That means difference in the energies we would get. And as they are given, it is a harmonic oscillator. So we know that energy for the nth level nth state of the harmonic oscillator is nothing but n plus half h cut omega. So E4 is nothing but 4 plus half h cut omega, and E2 is nothing but 2 plus half h cut omega. So we just need to subtract this. So this half would get cancelled. 4 minus 2 is nothing but 2 h cut omega. So this is the remaining. So in the place of E4 minus E2, we need to just write 2 h cut omega t by h cut, and here it is minus 1, so minus 1, and we know that cos pi is minus 1. Cos of minus pi is also minus 1 only, because cos of minus theta is nothing but cos theta, and cos pi, so in the second quadrant cos is negative, so cos pi minus 1. So we can write this in this form: e power minus I pi, that is nothing but e power I theta is nothing but cos theta plus I sin theta, based on this simple formula. As we know, e power I theta is equals to cos theta plus I sin theta. So I sin theta, so cos pi minus 1, sin pi is 0, so we would get minus 1, however, so this could be written in this form. So you are making in this form so that bases would be equal, means then their corresponding exponents would be equal. That means this is equal to this. So minus I would get cancelled. 2 omega t is equals to pi, and t is nothing but pi by 2 omega. So this is that time. So after this time, xi of x comma 0 would be orthogonal to xi of x comma pi by 2 omega, that is t is nothing but pi by 2 omega. So this is the problem. Pi by 2 omega is the answer. So pi by 2 omega. So the correct answer for this question is pi by 2 omega. So after this time it would be orthogonal. So this is the problem. So thank you.